POSIX file system. POSIX, and just like ext3 is, just like ZFS is, except it scales to extreme ends. It can aggregate petabytes of storage into one aggregated namespace. You can have tens of thousands of clients accessing the shared storage in one namespace. It's high performance. We connect to many different types of networks, and we have high performance networking and routing, high availability features, including failover and unattended failover. Lustre is open source. It always has been and will always will continue to be. Runs on multiple platforms, and it's available from multiple vendors. So Sun is the best place to get Lustre, but it's not the only place to get Lustre. And it's based on a very modern object-based architecture. So that's Lustre in a nutshell. The Lustre deployments today, as of about November 2007, IDC claimed that we had the largest market share of all file systems in HPC. And we've been adopted by the largest supercomputers in the world, including the #1 computer in the top 10, Blue Gene L, at Lawrence Livermore National Laboratory, and 7 of the other top 10. That was based on the November numbers. I'm interested to see these June numbers and how they pan out for us. 30% of the top 100 computers in that list run Lustre. So all of a sudden, I'm starting to see that this company that wasn't really real has actually accomplished quite a lot, including most of these partnerships were in place by CFS, and we brought these partnerships over to Sun and fully embrace them and honor them. So Bull and Cray, DDN, SGI, all of these companies are still very strong partners of ours, continue to integrate solutions based on Lustre and other open source technology. And some of them are even looking to Sun now in the compelling open storage offerings that we have and considering selling those to their customers because they see compelling integration, price performance value in these Sun storage offerings. And growing, even though we've been traditionally known at the very high end of HPC, we have growing success in commercial marketplace as well, in oil and gas, in rich media companies, ISPs, and chip design companies, and more. So we will continue to carve out the very high end of HPC with Lustre. We don't want to give up in that territory. We want to continue to push the envelope of performance, but also continue to provide compelling value in open storage solutions into the commercial market. So when we think of Lustre, we really need to think of extreme HPC. And what does extreme HPC look like? Well, Blue Gene L, the top computer in the top 500 for a couple of years running, I think now, 1.9 petabytes of storage, so that's one namespace. A respectable 35.6 gigabytes per second of aggregate throughput through that storage cluster. But this number here is particularly impressive for us. Over 200,000 clients connect to the file system and run jobs simultaneously on the file system. So that's what we see as extreme. TAC Ranger, hopefully we'll see it claim a #2 spot in the top #4. Okay, well, that's still respectable, but we'll definitely see it in the top 10 at this show. 1.73 petabytes of storage, so definitely one of our larger deployments. A very respectable 40 gigabytes per second of throughput, and almost 4,000 quad-core clients. No record set there yet. On the client count, I think that Sandia Red Storm is definitely the biggest number of direct connect clients, 25,000 clients, and I think that in the coming months, within 6 months, that'll probably be 35,000 or more if things go according to plan there. A measly 340 terabytes of storage, nothing much really to talk about there. 50 gigabytes per second is pretty good, but not as good as CEA Terra 10, which holds not the top record, but what we consider a production quality record of 100 gigabytes per second of I/O throughput on a petabyte storage and just over 4,000 dual core systems. So these are some of the premier systems. We continue to set a number of different records with Lustre, up to 4,000 object storage, 4,000 object storage targets, connected to up to 450 object storage servers. Today we have a maximum file system size of about 32 petabytes. No one's hit this limit yet, so we haven't really had an opportunity to try to exceed it. But with going to ZFS in the near future, we will see that limit exceeded. For metadata operations, best number we've hit to date is 15,000 metadata operations per second, but we'll see that be able to inch up into close to 1 million in the coming year with clustered metadata. So as I said, CFS was a little company a year ago. On October 1st, we completed our integration into Sun. And so at supercomputing in November, Peter Bojanic got up and talked about what our plans were for the integration, and that we would honor all of our commitments to our partnerships and so forth. And so I'm very proud to say that theme of continuity has been successful, successfully maintained by Sun and successfully honored also by our partners. No employees, partners, or customers were lost in this transition period, which has been a tremendous success for us. The software remains licensed under the GPL and available on Linux as our premier platform right now. But Sun actually encouraged us to go a step further. And while our source was open before, there were other elements that weren't. And since we've joined Sun, we've also published all of our design material. Is available through the Lustre community websites. Our CVS source code repository is now open, so you can grab the latest source code right from CVS with an anonymous checkout. And even our internals course is open and available on the lustre.org website. It was a course that we've taught only a couple of times, but provides some valuable information into understanding how Lustre works. And all of our architectural discussions with Peter Bojanic, who remains our lead architect, and a number of our senior engineers, all these discussions happen out in the open now on Lustre Devel. So Lustre is even more open than when it was strictly under CFS. And not only do we honor our existing partnerships, we've continued to grow partnerships. So we've seen new relationships and new partnerships forming with companies to provide to resell Sun equipment, to integrate Lustre in with their hardware platforms and sell to customers, and then also to augment our service and support capabilities to make Lustre even more successful out in the field, even working with Sun customers. So turning to the Lustre roadmap, I will talk about each of these in a little bit more detail, but this fall we'll see Lustre 1.8 come out. This is a small feature maintenance release that introduces improved recovery. Lustre 2.0 will be a major new release coming out at the end of the year. Lustre 3.0 next summer will introduce our Solaris and DMU servers. And Lustre 4.0, a little bit less precise around specifically what we're going to be delivering in that time frame and in that release, but the summer of 2010 is what we're currently considering. Lustre releases in the past, people who have known us for a long time know that we've jammed a lot into maintenance releases and into dot releases. I think Lustre 1.4 has been the kind of the production release for 2.5 years before we put out Lustre 1.6, maybe even longer. So we've shifted to a more traditional release taxonomy. We'll be incrementing that first digit a lot more frequently and reserving the dot releases just for feature enhancements and maintenance releases strictly when the third digit increments. So the importance here is that customers and partners alike will be able to better understand when we talk about release numbers and what's going into release numbers, kind of how big or how risky those types of changes will be. And we hope that this numbering will make it a lot clearer for everybody. So Lustre 1.8, which is coming out this fall, will introduce a modest set of new features. The idea here is that the customers like Livermore and Cray customers who are running some really big computers will be able to adopt these releases a lot more readily. TAC will be able to contemplate a release moving to a release like this when there's fewer features that they have to test in their environment. So we'll improve recovery. Protocol interoperability will introduce between the current generation of Lustre and the next generation of Lustre, which will be released in Lustre 2.0. We need to make sure that you can do these rolling upgrades. On these enormous storage clusters, you can't just turn them off and reboot them and upgrade. You actually have to keep them going, clients and servers alike, and do these rolling upgrades. Service tag support, so you'll be able to optionally register your Lustre installation and get some service and support options. And this will be based on the existing code base that Lustre 1.6 is running today. It will not be based on the new code base, which is coming out in Lustre 2.0. So in Lustre 2.0, we'll introduce major architectural changes that we've been working on for some time. Security, so Kerberos authentication and encryption will be available in this release. We'll also be introducing replication and search interfaces for a number of customers that we're working with for wide area deployments. A network request scheduler for improved performance over the cluster, and HSM will likely debut in this release. This will be based on HEAD, on the big development branch that we've been working on for a couple of years, that provides a foundation for clustered metadata, but clustered metadata will not yet be supported. Clustered metadata will come in Lustre 3.0, and at the same time, this was also when we'll introduce the DMU servers, because as we've been working on ZFS integration and bringing clustered metadata to maturity, we've been tying these things much more closely together, much more intimately. So in all likelihood, we will end our LDiskFS support in Lustre 3.0. You will still be able to migrate over your existing services to ZFS services, but clustered metadata in Lustre 3.0 will much favor the ZFS platform. And then there will be migration tools available as well to get over from your ext3 deployments to your ZFS deployments. So data integrity is one of the compelling features. As Peter Bojanic mentioned, what ZFS provides is this on-disk data integrity. So it makes sure that what gets written to the disk stays on the disk in a form that you can get it back. But Lustre adds to that data integrity. So when we write data to the storage server, we do a checksum before we put it over the wire and do the network DMA, and then after the storage server gets it. And this was a very important feature that we introduced some time ago to some leading customers. It just rolled out in Lustre 1.6.5. It's turned on by default, because we found that there were inexplicable data corruptions landing on people's disks. And after a lot of exhaustive research, we found that there were actually a number of networking cards that were silently corrupting this data without it generating any errors. So Lustre has this data integrity checking over the wire today. ZFS provides the data integrity checking on the disk, and Lustre and ZFS offer this compelling value that, as far as we understand, is not available in any other storage solution in the industry, of end-to-end data integrity, so that what you send over the wire can be guaranteed to be written and persist on disk. We achieved a really significant milestone earlier in May. We announced this at the Lustre Users Group, that for Lustre, we expect to achieve 90% of the raw disk bandwidth out of the DMU in ZFS. The numbers that we were talking about previous to this were about 50% of what we could get with LDiskFS. And so we've broken this barrier, we've broken this major milestone, and we can expect that the DMU, with a certain number of patches that are yet to be written, but zero copy being one of the premier contributors to this performance level, will give us on-par performance with what we have today on Linux with LDiskFS. So this was one of the biggest risks that we've been managing for some time, is can we get the same performance out of ZFS as we can out of LDiskFS? And now we have great certainty that this is achievable. By the way, raw ext3 without any of the Lustre optimizations applied to it is that first bar. So you can see that there's a kind of enormous gap in between what the unrefined file systems can achieve and what you can get with Lustre. The HSM collaboration with CEA in France moves ahead quite well. They introduced a high-level design last January. They've got code that will be running this summer that we hope to get into Lustre 2.0 for the end of the year. They're working on HPSS integration. At Sun, we're in the early planning stages for SAM QFS integration. You can archive to SAM today, but it's more of a data mover type thing. Between Lustre and SAM QFS, we will have a much tighter integration with this HSM feature. And discussions are underway with SGI for DMF integration. Lustre PNFS was introduced by Peter Bojanic in his talk. So we see PNFS as essential for the enterprise. It's what's going to bring Lustre into commercial deployments. Not every platform can run the native Lustre client. Windows, for example, is not there yet. So PNFS will provide higher performance than monolithic NFS servers and support for larger unified namespaces. And on Linux, we've already had several technology previews of PNFS support. We'll continue to move that forward. And on the Solaris side, bringing much richer PNFS protocol servers running layered on top of Lustre, so that when we see these products working together, you will be able to combine PNFS servers onto Lustre metadata servers and Lustre object storage servers, and then you'll also be able to have pure exports of CIFS and NFS servers and parallel NFS servers on different nodes, all bound together by the Lustre high performance networking interconnect. For clients, the PNFS client for Windows, that's our parallel CIFS exports for Windows, is under early customer evaluation presently. We are doing benchmarking with clustered Samba exports with Lustre and seeing numbers that compare quite favorably even to CIFS server on Solaris. So we see that this provides a good performance solution for Windows clients today with a purely open source, as a purely open source solution, whereas our PCIFS client and the Windows client, native client port that we're working on will be proprietary offerings and not strictly open source offerings. A Solaris client port is in the early planning stages, and a client portability library that enables this client porting to Solaris and to Windows and potentially to other operating systems as well is in the works. As we continue to push the limits of Lustre performance, the networking request scheduler will allow us to achieve higher I/O throughput and better coordination of I/O across the cluster. Flash cache gives us optimized performance using new flash technology that's coming available from Sun and from other vendors. And the client metadata write-back cache, which is looking like 2010 timeframe, will bring near local file system performance to Lustre clients. So that's all I had prepared for you today, and I think I'm out of time, so I think Harriet is up next.
Well, thank you, Peter.